Welcome to this week's edition of the Pale Blue Dot Narratives. As the Earth tilts toward its most sun-drenched moment in the Northern Hemisphere, we begin with the summer solstice, what it is, why it happens, and how it's shaped cultures and calendars for thousands of years. It's more than just the longest day. It's a cosmic alignment that reminds us of our place in a dynamic solar system. From the light of the sun, we shift to the shadows of the universe. Black holes, those mysterious wells of gravity, are no longer just theoretical. Thanks to the Event Horizon Telescope, we've glimpsed their edges. And now, with next-generation upgrades, astronomers are pulling back the veil even further, capturing details once thought impossible. Finally, we return to Earth and inward to the body, where science is uncovering how stress interacts with our biology. While it's not a cause of cancer, chronic stress may play a role in how illness takes hold and how recovery unfolds. We'll explore what that means for the future of cancer care and the growing interest in mind-body approaches. 3 different realms: celestial, cosmic, and cellular, each with stories that challenge how we see the world and ourselves. Let's begin. In this segment, Eco Insights, where we uncover the science behind the natural world and their impact on our planet. Every year, around June 20th or 21st, the sun appears to stand still at its highest point in the sky, ushering in the summer solstice for the Northern Hemisphere. It's the longest day of the year and a turning point in Earth's seasonal rhythm. But behind that simple fact lies a deeper story about how we move through space, how we grow our food, and how we've built entire cultures around the sun. Let's start with the basics. The summer solstice happens because of a cosmic tilt, literally. Earth leans on its axis at about 23.5 degrees. During the June solstice, the North Pole is tilted as close as it gets toward the sun. This means the sun's rays shine most directly over the Tropic of Cancer, giving places in the Northern Hemisphere their maximum daylight hours. It's a moment of contrast. While we in the North are basking in long sunny days, the Southern Hemisphere is experiencing its winter solstice with the shortest daylight of the year. 2 halves of the planet, lit so differently, all due to a gentle tilt. Now, how does this compare to an equinox? Well, equinoxes occur twice a year, around March 20th and September 22nd, when Earth's tilt is sideways to the sun. On those days, the sun sits directly above the equator, and day and night are nearly equal all over the world. Think of equinoxes as moments of balance, while solstices are the extremes. Here's a common myth worth busting. The summer solstice doesn't happen because we're closer to the sun. In fact, Earth is actually farthest from the sun, a point called aphelion, just a couple of weeks after the solstice. So why is it so warm and bright? It all comes down to the angle and duration of sunlight. The sun takes a longer, higher path through the sky, delivering more daylight and more energy to our hemisphere. And that energy has shaped agriculture for millennia. For ancient farmers, the solstice wasn't just a marker of time, it was a signal. A cue to watch crops carefully, to prepare for harvest, to celebrate nature's abundance. Without modern calendars, they used the sky to guide their work. Civilizations across the globe aligned their temples and monuments, like Stonehenge and Machu Picchu, with the rising or setting sun on the solstice. Even today, longer daylight hours mean more photosynthesis, which means more growth. Crops like wheat, corn, and barley thrive during this peak. And while modern agriculture runs on technology, the seasonal light cycle still influences planting schedules and yield potential. Beyond science and farming, the solstice has deeply influenced culture and spirit. From midsummer festivals in Scandinavia, to bonfire dances in Eastern Europe, to solar rituals in ancient Egypt and Inca ceremonies in the Andes, people have long gathered to mark the sun's power at its peak. The word solstice itself comes from Latin, solstitium. Sun stands still. And perhaps that's exactly what it invites us to do, to pause, to observe, to marvel at this quiet cosmic choreography that gives us our days, our seasons, and our sense of time. The solstice is more than a date on the calendar. It's a reminder that we are all passengers on a tilted planet, tracing a path around a glowing star, and that even a few degrees can change everything. In the next segment, Cosmic Conversations, where we delve into the latest discoveries and debates shaping our understanding of the universe. Imagine trying to photograph something that eats light. Something so powerful, so massive, that even time seems to slow near its edge. For decades, black holes were theoretical beasts, inescapable pits of gravity predicted by Einstein, hinted at by strange motions of stars and gas, but never directly seen. That all changed in April 2019, when humanity got its first image of the shadow of a black hole. It wasn't taken by one telescope, it was taken by many, working together across the globe. This remarkable image of the supermassive black hole at the center of galaxy M87 was the work of the Event Horizon Telescope, or EHT, a planet-sized array of synchronized radio observatories that acted in unison to peer into the abyss. So what exactly is the EHT? The Event Horizon Telescope is a collaboration of observatories spread across Earth, all using a technique called Very Long Baseline Interferometry, or VLBI. This allows scientists to combine data from radio telescopes thousands of kilometers apart, effectively simulating a telescope as big as the planet itself. The result? The highest resolution images in all of astronomy. Each telescope in the network plays a part. From the dry heights of Chile's Atacama Desert to the icy plateau of Antarctica, and from the peaks of Hawaii to the mountains of Spain, these observatories are carefully chosen for their elevation, dryness, and geographic spread. Together, they form a globe-spanning eye trained on the most extreme objects in the universe, and the work isn't done. A new chapter is about to begin with the next-generation Event Horizon Telescope. This expanded array will add 10 to 20 new stations, filling in coverage gaps and offering continuous high-resolution imaging. Most excitingly, it will allow researchers to do something never done before: create time-lapse movies of black holes in action. Imagine watching, frame by frame, how matter spirals inward, how jets erupt outward, how magnetic fields twist in real time around a cosmic void. But the EHT doesn't operate alone. It works in tandem with some of our most powerful space telescopes. The James Webb Space Telescope, for instance, reveals cooler dust and gas in galactic centers through infrared light. Chandra sees the X-rays blazing from hot material close to the event horizon. And Hubble, still a stalwart after 3 decades, in orbit, helps track the colossal jets launched by black holes into intergalactic space. Together, they form a multi-wavelength alliance, each instrument adding a piece of the puzzle. With EHT providing the close-up and telescopes like JWST offering the cosmic context, scientists are uncovering how black holes shape the very galaxies that host them. This partnership is already bearing fruit. In the case of M87, the EHT showed us the black hole's shadow, while Hubble and Chandra traced its massive relativistic jet. For Sagittarius, a star, the black hole at the center of our own Milky Way, EHT revealed a flickering, chaotic ring of plasma, consistent with a quieter, feeding black hole. And polarized light studies are now helping map magnetic fields near these cosmic giants. All of this has deep implications, not just for astronomy, but for physics itself. These observations test Einstein's theory of general relativity at its limits. They help us probe how energy escapes these objects, how jets are formed, and how galaxies evolve over cosmic time. The idea that we can now see black holes is revolutionary. But what's coming next? Moving images, dynamic behavior, and even finer details might just be the biggest leap yet. Thanks to global coordination and the marriage of Earth-based and space-based science, we're no longer just imagining the edge of the universe. We're watching it, pixel by pixel, unfold before us. In the last segment, Health Beats, your trusted source for the latest in medical breakthroughs, we're exploring an important and often misunderstood question. Can stress influence cancer? And can calming the mind really help the body heal? Let's be clear from the start. Stress does not cause cancer. That's not just a cautious statement. It's what the science says. There's no clinical evidence that emotional stress directly triggers cancer cells to grow or spread. And practices, like meditation or yoga, while beneficial in many ways, are not cures or treatments for cancer. That said, researchers have found some fascinating connections between chronic stress and the biological environment in our bodies. And that's where the story gets interesting. Let's begin with the stress response itself. When we feel anxious, overwhelmed, or threatened, our bodies react by releasing hormones, specifically norepinephrine and cortisol. These chemicals are helpful in short bursts. They sharpen our focus, raise our heart rate, and get us ready to handle challenges. But when stress sticks around for weeks or months, these hormones stay elevated, and that can change how the body functions in more lasting ways. One process affected by stress hormones is called angiogenesis. Now, angiogenesis is the body's way of building new blood vessels. It's a healthy and natural function, but in cancer, it can be hijacked. Tumors can trigger angiogenesis to build their own blood supply, feeding themselves and growing faster. Research suggests that norepinephrine, one of the main stress hormones, may encourage this process. It may help tumors become more nourished and aggressive. Another process is metastasis. That's the spread of cancer cells from one part of the body to another. It's often what makes cancer so dangerous. Studies, mostly in lab settings, show that chronic stress may influence certain enzymes and chemical pathways that make it easier for cancer cells to move and invade new tissue. Again, this isn't proof that stress causes cancer to spread. But it does suggest that the internal environment of a stressed body could be more permissive to certain disease processes. Then there's cortisol, the other major stress hormone. This one works more like a slow drip. When cortisol stays high, it can suppress parts of the immune system, interfere with cell repair, and even disrupt normal cell death, which is a built-in mechanism the body uses to remove faulty cells. Think of it this way. Long-term stress may not start the fire, but it could be removing the fire alarms and cutting the water supply, making it harder for the body to do its job effectively. So where do mind-body practices fit into all this? Meditation, yoga, breathing exercises, and therapy do not treat cancer, but they can support a person's overall well-being. Studies show that these practices may reduce stress hormone levels, improve sleep and mood, and even support aspects of immune function. Hospitals like Memorial Sloan Kettering and MD Anderson now offer these tools through integrative oncology programs, not as a replacement for treatment, but as a way to help people feel better, cope better, and recover more fully. Here's the takeaway. While it's not scientifically confirmed that stress causes or worsens cancer, taking care of your mental and emotional health is still one of the most powerful things you can do. Supporting your inner world, your thoughts, emotions, breath, and awareness can help you meet life's challenges with greater clarity and strength. And when your body is going through something as serious as cancer, that kind of support really matters. So whether you're facing a diagnosis, supporting a loved one, or simply navigating the stress of modern life, take a moment to breathe, to reflect, and to care for yourself. It's not about fighting stress. It's about responding to life with balance. That wraps up this week's journey on Pale Blue Narrative. Thank you for joining us as we explored the latest breakthroughs at the edge of science and technology. If you enjoyed today's episode, be sure to subscribe and share Pale Blue Narrative with fellow curious minds. Your support helps us continue shining a light on the wonders of our universe. Until next time, keep asking questions, stay inspired, and never stop exploring our extraordinary pale blue dot.